I welcome you all for the session 11 on interference of light. Okay, in this session, we shall discuss about the biprism. Prism is an optical medium bounded by three rectangular faces and two triangular faces. A biprism consists of two thin prisms with their bases joined and their two faces making an obtuse angle of about a 179 degree, so that other angles are each other of about 30 degree. In practice, the biprism is constructed from a single glass plate so that it is ground to have the required angles. When biprism is held symmetrically at a short distance from illuminated slit, the wavefront is divided into two parts. Each half of the biprism intercepted by one half of the wavefront produces a virtual image of the source S by refraction. The distance between the sources S and biprism P is so adjusted that the two virtual images S1 and S2 are quite close to one another. The waves from the two virtual sources superimpose and produce interference fringes in the region of superposition AB on the screen as shown in the following figure. Okay, this is interference by biprism. Here S is a source and S1 S2 are the two slits through which wavefront passes, and XY is the screen. This is a figure for the interference by biprism. A closely spaced fringe system is produced only in the region AB, while the wide set of fringes are formed at the edge of the pattern on account of diffraction. Since interference fringes are narrow, they are generally observed using a low power microscope so that the fringes formed in the focal plane of the microscope are observed. The determination of the wavelength of monochromatic light. Theory of biprism is same as the theory of interference discussed in Young's method. The fringe width beta is given by the formula beta is equal to lambda d divided by small d, where lambda is wavelength of the radiation and capital D is the distance between the slit and the screen, and small d is the distance between the two virtual sources. Procedure of the determination of wavelength of monochromatic light. The slit S, the biprism P, and a micrometer eyepiece E are mounted at the same height along a straight line using three uprights capable of vertical and transverse adjustments fitted on an optical bench. The slit is illuminated by the monochromatic light of wavelength lambda, which is to be determined. The biprism is moved at right angles to the optical bench so that on looking through the eyepiece holder, two bright virtual slits S1 and S2 are observed. The eyepiece is moved perpendicular to the bench so that overlapping region AB is brought in the field of view and the fringes are obtained in the focal plane. Well-defined fringes are obtained by arranging the refracting edge of the biprism parallel to the slit by rotating the biprism suitably. Then measurement of a fringe width beta. The center of a particular fringe, bright fringe, is brought on the crosswire of the micrometer eyepiece, and a reading for this fringe is noted using a micrometer eyepiece. The position of the crosswire is moved to the one side until 5 fringes cross the field of view using slow motion screw, and a reading for the fifth bright fringe is noted. The same procedure is repeated to note the readings for 10th, 15th, 20th, 25th and 30th fringes. The readings are tabulated and the width of 20 fringes, and hence its mean value is calculated from the mean width beta 1 is equal to beta 1 of 20. Measurement of distance d. The distance d between the slit and the focal plane of the eyepiece is mounted with the help of a scale on optical bench. Measurement of distance between the virtual sources. A convex lens is suitable focal length is placed between the eyepiece and the biprism without disturbing their position. The position of lens is adjusted to get a magnified image of the slits. The separation between the two magnified images x is noted. If small d is the distance between the two slits, then the magnification is given by m is equal to x by d, which is equal to v by u, image distance divided by object distance. The position of a lens is again adjusted to get a diminished image of a slit. The distance between the two diminished images y is determined. The magnification of a diminished image is given by m1 is equal to m2 is equal to y by d, which is equal to u by v. Therefore, m x m2 is equal to xd divided m1 into m2 is equal to x by d into y by d, which is equal to v by u into u by v, which is equal to 1, and hence x into y is equal to d d2, or d is equal to d square, and d is equal to square root of x into y. Knowing x and y, the distance between the slits can be calculated using the equation 4. Thus, by knowing the fringe width beta, small d and capital D, the wavelength of monochromatic source is calculated using an equation beta is equal to lambda d divided by capital D. Call it as equation number 5. Okay, we shall discuss about some of the questions on this session. The first question: the prism is an optical medium bounded by dash faces and dash faces. Option A, 3 rectangular and 2 triangular. Option B, 2 rectangular and 3 triangular. Option C, none of the above. The answer is option A, 3 rectangular faces and 2 triangular faces. Prism is an optical medium bounded by 3 rectangular and 2 triangular faces. Therefore, answer is option A. Second question: a biprism consists of dash thin prisms. Option A 1, option B 2, option C 3, option D none of the above. Biprism consists of 2 thin prisms. Therefore, answer is option B. Thanks for patient listening.